right, I think that's all the major announcements I wanted to make. So we will get the program started, and I would like to first introduce our host, Kirsten Mateus from BMW. So Kirsten, please.
Well, thank you, Rudy, for the kind introduction, and welcome everybody. I'm really, really happy to have you all here, and I'd like to thank you all for making the effort of being here in person, being virtually at the event. We have as many people almost virtually as we have in the room, and that's really nice, and I hope that next year we can all meet personally, also those that weren't allowed to travel this time. So you all know, probably, I'll show you, this is the anniversary. This is a photo from the first event that we had 10 years ago down at the FITS Forum. That's me on the photo. That was the first event I ever moderated. That's not so important on the photo. What's more interesting is we have the full agenda in the background that you can see of all the presenters and the presentations. And we have at least two people, I don't know whether they have all arrived, but we have two people here today that actually gave presentations at that time, and we'll talk more about the how it sort of changed from the first event to how it is today, tomorrow, in the keynote that we have for the next 10 years. So we have the first photo here. That's Olaf Krieger from Volkswagen Stellantis. I don't know whether he's arrived yet. He has. Hello, Olaf. You don't have a presentation this time, but you had one at the first event, and the second one, Lars, who's down here, and we'll see him after the keynote with the first presentation from today. And with that, I'd like to, just hope we all have a really good time. I'd also like to encourage those people online that send your questions in the chat. Rudy will take care of the online questions that you post, so that when you have questions to the speakers, you can participate as well as everybody who's live and who has to go up to the microphone. So with that, I'd like to introduce our first keynote speaker. That's Graham Smethurst, and I actually have another photo. That's also from the first event, and that was the panel discussion at the first event. And Graham actually was at the first event. At that time, the keynote panel, the panel topic was standardization, because we were right at the beginning of automotive Ethernet. Standardization at IEEE hadn't yet started. We were in the first discussions about it. At the time of the event, we had just published the Open Alliance, just went live the day before the event, which of course was not by accident, but it was planned to have to be that way. And Graham was part of the panelists at that first event. So, and he's now heading in the research department of BMW today, after 30 years in the automotive development, the in-vehicle networks and BoardNet. And his presentation today is from vehicle-centric to people-centric. And with that, I'd like to welcome Graham. And the floor is yours.
So good morning, everybody. It's a great pleasure to be back 10 years later, and also something of a novelty to have a real audience. What I'd like to talk about this morning is basically do a quick retrospective. Where have we come over the last 10 years? And then look forward in terms of where are we likely to go in the next 10. So 2011, particularly interesting year. For me personally, going back to the panel, it was 2 years after the launch of Geneva, and it was 2 years before our first BMW Linux head unit. So it was, You might think I look stressed on that picture. It's probably because I was in a head unit task force. But in 2011, we were still very much in the transition from domain-specific buses. BMW was, I think, the first one to bring Ethernet into the vehicle in 2008. The focus was very much about increasing processing power and infotainment, connecting CE devices, connecting to the cloud. At the time, we thought the car was already fairly complex with 10 million lines of code. It's funny how things change. And that was the point, really, that it was the hockey stick. It was when things really started to kick off in terms of variance, in terms of vehicles, where the portfolio of vehicles changed from a core set of vehicles to a much wider variety of customer offers in terms of vehicles. If we look at 2021, we're looking basically with the launch of our new iX at more mature domain architectures. But fundamentally, between 11 and 21, the domain architecture was consolidated. We already had the first of the powerful integration platforms, and both Ethernet and what I will carefully call legacy buses coexist in the vehicle. The focus is very much on diversity of powertrain, moving on from petrol and diesel into electric and hydrogen, and the deep integration of CE, or consumer environments, into the vehicle. Still very vehicle-centric, still trying to make sure that the customer experience outside of the car, as far as possible, is represented within the car. For us at BMW, it's also significant the introduction of data analytics, so access to more vehicle data for diagnosis, and the use of remote software update. This is a topic I'll come on to further on in my presentation, but a very important topic, being able to maintain that vehicle after point of sale and after the SOP. A factor of 10 in terms of software in the vehicle. The complexity in the vehicle now is, well, it's mind-blowing. It's almost incredible that we actually managed to build, manufacture, sell, and maintain products of such complexity, especially when you consider how many launches we have in a year. When I came to BMW back in 2000, it was all about the 3, the 5, and the 7 series. And everyone was going, oh, we're launching this new X5 thing. And oh, 4 vehicle lines, that's unbelievable. And you now look at the diversity, the number of vehicles, the number of vehicle types. It really is mind-blowing. So if you look at where we are, basically we have domain ECUs in a 2021 architecture, cockpit or head unit, body controllers, powertrain, and then the emerging topic of automated driving. The question is, where do we go from there? Now, I have the comfortable position of being a research guy right now. After 30 years in product development, I can now sort of zoom out a little, look at where we are in 21, and using my Glaskugel, my crystal ball, try and predict where we're going to go with these architectures. What's also interesting, in the last, let's say, 18 months as a research group, we've been working very closely with our production colleagues to define what is the next step for BMW. What you will see is a transition from the domain architecture into a zonal architecture. What does that mean? Well, for the guys who do the vehicle harness, it's great news. You know, they can now do a much higher degree of modularity in the harness manufacture and installation. It places a new set of requirements on communication. And to our mind, that places Ethernet center stage. Yeah? The idea is to bring in a true backbone bus. And we said earlier, we had a lot of local buses. These buses we want to reduce step by step to the point where we have a true backbone. What's key here is the scalability of the Ethernet switches, Clearly, if we've got a true Ethernet network, then we want to avoid as many gateways as possible to avoid the translation of data from one form to another. That's simply inefficient. Yeah? We need a chain through the vehicle that is very performant and, of course, very cost sensitive. We're working hard on our service-orientated architecture to get to the point where we can make the signals that run over the buses usable in a very easy manner, which has not always been the case when we look at our boardnets architecture. And for us, the next step is the scaling of the Ethernet architecture. We already have Ethernet deployed in the vehicle in a number of points. That we will increase, so we have less legacy buses and more Ethernet. If you consider what challenges we have before us, we see two big challenges. The vehicle fleet is basically getting older. Now, you could say this is good news because the quality of the product is improving and the cars can stay longer in the field. But this is also a result of changing usage models. The way in which people own and use vehicles is not the same now as it was 10 years ago, and it certainly won't be the case in 10 years' time. When you look at what's going on in Glasgow at the moment with COP26, all the discussions about how we will address the issues that face us in terms of protecting the environment. What this means is that gradually cars are becoming older. I mean, I only have figures for Germany, but if you look in 2020, the registered cars in Germany, 9.6 years old. If we go back to the year 2000, they were less than 7 years old. So there's a definite trend towards older vehicles in the field. So what does that mean to us? Well, this doesn't change customer expectation. If a customer's driving a car that's 10, 20 years old, they don't want to drive an antique. They still expect performance and functionality, and the challenge for us as an engineering community is how do we provide that? What we expect is, in future, the costs and revenues after point of sale will become really quite significant. And the question is, how do we produce an architecture that will support this trend? The second trend that we see, like I say, I've been in the automotive industry 30 years. The car has been, still is to a large extent, the center of my life. But that's not always the case. And I must admit, I spent some time living in Berlin where I didn't really need a car because I lived in the city. What we see is a shift away from vehicle-centric to people-centric. I want to be able to interact with my car as one of my connected devices, but not my sole connected device. If I'm using my smartwatch, if I'm using my mobile phone, if I'm wearing my augmented reality glasses, all of these things are going to have to react or interact with my car. Maybe I'm lucky enough to have more than one car. Maybe my cars don't come from the same manufacturer. Still want to use the same augmented reality glasses. Still want to use the same mobile phone. It's about personal devices and about my interaction with my connected devices, of which the car must be one. So if you consider these two trends, the question is, well, how do we solve this? And unfortunately, it's quite complex. And I'm going to start on the top left-hand side. Melvin Conway, 1967. What he suggested was that organizations are only able to produce solutions that mirror their organization. Now, the problem we have, the challenge that we have in migrating from a domain-based architecture to an architecture that contains integration platforms, that challenges the organization. And the question is the organization prepared to come up with a technical solution that supports these ideas of being able to update the car and being people-centric? Seems strange to start with organization, but it's one element that has to work in the transition to a true integration platform if you're to cluster the right functions onto that integration platform. The next topic is process. This is one of my favorite slides. It's an old slide, so I can't say that it's true today. This was published in 2013. And my question is, in a system of this complexity, how do we do an update? Yeah, I've already said at BMW we have remote software update already. The question is, if you have to do this over an extended period of time, yeah, for multiple vehicle lines, perhaps for different technical implementations of an architecture, how do you do it? You have to know your system. You have to know exactly who relies on which signal to do what. Yeah? That's a challenge in a system of that complexity. So if I come to the architecture, I think this is one of Kirsten's slides that I've stolen here. We still have diversity in terms of the network technologies that we use. And it sounds like maybe a crazy statement, but the car has to be designed to be updatable. And when we started designing these architectures, probably 20 years ago, yeah, updatability wasn't the issue that we have today, and the problem will intensify. So the question is, well, what's a reasonable approach? In my mind, it means going back to basics. Yeah. This is a very simple representation, but what I will try to do is explain the logic. If we take ASIL as a basis, something we all know and understand, if we're to say we're going to have a logical backbone bus, and that logical backbone bus connects the car, it is the mainline plumbing in the vehicle, it is also the mainline plumbing to the back end, to the cloud. Because again, this hard differentiation between what happens in the car and what happens in the back end, that is no longer a hard boundary. It cannot be a hard boundary. And IP and Ethernet is exactly the right technology to join these two worlds together. But if we were to do a clean partitioning of ASIL C-D functionality into one integration platform, and then the more QM side of the business into another integration platform, why would you do that? Well, basically because the processes necessary to deliver an ASIL D component are very, very different to the processes you need to deliver a QM-based component. The validation, the design methods, the process you need to go through to perform an update are very, very different. Now, today there are examples of where we mix these two things together, and these are just the two bookends in terms of the functional partitioning. What we also need is one component that provides the bridge. Yeah? It connects these two worlds together and effectively provides a firewall between what really matters in terms of driving and using the car and what is, to a large extent, a nice to have, a convenience. Now, strictly speaking, if the green integration platform was to fail, yeah, we would have disappointed customers, but they would still drive from A to B. Yeah? They wouldn't be left on the side of the road. What you also need to consider is, if you want to update the vehicle, yeah, basically all of these will need to be updated, but the process that you go through to update them can be and should be very different. If we look at the process briefly, I've called it at the bottom here the hard core. Yeah, this is the heart and soul of the vehicle. This is what moves it, allows it to brake, allows it to steer. We have well-established processes. It's unlikely we will change those processes. They're stable, they're robust. They have to be. Yeah? So, yes, it will be possible to update that area of the car, but the process you go through to do this isn't likely to change significantly. If you then move up this stack, you move towards this yellow integration platform and the bridge. If we could actually decouple or separate the hard core, yeah, from what goes on elsewhere in the vehicle, then you can start to consider updates that are actually perhaps in a different process to the one that we follow today. Not in the hardcore process, so we don't replace hardcore, we augment hardcore. Yeah? And then you get to the very top of the stack where you say, well, these are onboard apps. Yeah? This is your Netbooks, Flakebit, Spotify, Netflix, whatever it might be, but that's basically on demand. But without getting this separation between hardcore and the apps, you can't get the update rate. So fundamentally, you have different update cycles depending on which area of the vehicle you want to address. Now, if we look at that in something of a technical architecture, this is the same, what I'm calling traffic light architecture. If we add this to the zone modules, we add this to other devices that are connected to the Ethernet, you can see here it's relatively straightforward to create a secure zone. An area in which you basically are very, very careful, have very tightly controlled processes to make sure that that area of the car remains secure, stable for the customer. If you look at different functions, and this is where it becomes interesting with the logical backbone bus. If we look like a relatively simple function like a remote door unlock, yeah? I want to trigger the vehicle to unlock the doors from a back-end application. If you look at where that function actually materializes within the architecture, this chain of events between the various functions needs to be quick. If I click my key fob, I want my car to open. I don't want to wait 30 seconds for something to happen. Yeah? So there are a number of issues here that need to be considered. Ethernet in the car goes to sleep. Ethernet in the office doesn't. We don't have any start time issues with Ethernet Office because it's always live. But if I want to open a car door from a remote application and I'm running over Ethernet as a backbone bus, how do I handle the energy efficiency aspect? So maybe I can put it into a sleep mode or a hibernate mode so that when I need it to come back and provide my 1 second car unlock from a remote application, this is something we need to address within the Ethernet bus. If I take a different example, face recognition, for example, maybe the face recognition takes place on the green integration platform, but the cameras are all connected to the red integration platform because that's where I'm doing my automated driving. The question is, how do I get the information from the cameras that are connected to a red device to the processing for face recognition that I'm doing on the green device? Another challenge for the Ethernet backbone. And then we go really hardcore into something like brake-by-wire. All of this takes place in the secure zone between the red integration platform and the devices on the other side of the zonal architecture. Another set of interesting requirements for Ethernet if we use it as a backbone bus and a local bus behind the TIM. Seat heating. Again, an example of I want to trigger this from the green integration platform, but I have to go deep into the architecture. I have to get to the point where I actually get to the seat control module. Now, this is interesting. I mentioned people centricity, and then I started babbling on about Ethernet architectures and always fresh. If you look at this picture, the interface that's being presented from the hardcore vehicle to the rest of the vehicle is the same interface as is being presented to the back end and to the other devices that are interacting with the vehicle. So by solving this always fresh challenge, by partitioning the vehicle in such a way that we can update parts of it relatively easy, we can also use that interface to provide the interface to the outside ecosystems. Now this is particularly interesting. We're always talking about CE integration. How do I integrate CE or consumer electronics? How do I integrate that into the car? If you think about this the other way around, how do we integrate the car into the various ecosystems? How do we make ourselves as an industry more attractive to people who want to interact with the vehicle? So what we see as a number of to-dos, and we've already traveled a long way between 2011 and 2021, but we're not yet at the end of this journey. What we need to do next is basically consolidate the in-vehicle communication technologies. Yeah? We need TSN, we need traffic shaping, we need traffic classes, or we won't be able to handle the diversity of use cases that we want to implement using an IP backbone. Of course, we need security, and Ethernet is a super basis to provide that security for the hardcore part of the vehicle. We need to extend the network, we need more bandwidth, and we also need asymmetry. Yeah, we have specific challenges within the automotive industry with EMC, and we need to connect video, cameras, displays, and we don't want this to be an exception. Yeah, we've gone through the MOS generation, where we had an infotainment bus, basically. We need a backbone bus that will provide all of these use cases. We will, and we want to extend the vehicle Ethernet to the back end, so this becomes a seamless pipe. Yeah? No break in technology, no break in message transfer, in payload. And we need to address this topic of instant on. We need to be in a position where we can bring the car up to full functionality in close to zero time. Otherwise, when customers compare us to their smartphone, we're going to lose. We have to have an energy-efficient instant-on solution. And then to look at this from a software view, we as BMW, we want to identify an approach to establishing this vehicle device interface. We need it for our Always Fresh, and we need it as well if we're to integrate the vehicle into your ecosystem, my ecosystem. First question is going to be, what data and services are relevant on this interface? Yeah, it's not the case that we should boil the ocean and try and present all data. The question is, what is relevant? How will this interface be described over multiple vehicle generations? And how will this interface be governed? One thing that the successful ecosystems do, whether it be an Apple or a Google or a Baidu or all of these guys, they manage their interfaces. The interfaces that they present to their ecosystem are controlled, so you have a degree of continuity. And this is something that we as an industry also need to manage. Thank you.
You want to answer some questions, or you want to leave directly?
I can try to answer some questions.
Okay. One or two questions allowed, if anybody has one. Do we have any online? No online questions yet. Anybody who wants to ask a question, make use of the possibility you have right now? Okay. Well, no questions then. Thank you very much once more.